Okay, so we started oxidation reduction, or redox. We started a little bit into that last class. And remember, guys, the way that you know if an element is being oxidized or reduced is based upon, do you see this element changing its charge? Or let me use a fancier term. Do you see that element's oxidation state changing from left to right? If you do, then it's probably a redox reaction. Okay? So, just to refresh your memory, okay, an element that loses electrons has been oxidized. Now think about that for a second. Electrons are negatively charged. If something loses electrons, what should be happening to its charge? Should it be increasing or decreasing? Increasing. Good. Okay, so if something gains electrons, it's gaining negativity, it should be reduced, its charge will be decreasing. Okay? And guys, you will have questions, probably not many, but questions like this in multiple choice. I say not many because this is very, very easy. But you'll be given a reaction and it'll simply say, you know, which element is oxidized or which element is reduced. Right? So let's just quickly review that. What is the oxidation state of an element by itself? You got it. Here's another one. Sodium within a compound? +1. Chlorine? Okay. So, again, you're looking from left to right. Sodium goes from 0 to +1, so is it oxidized or reduced? Oxidized. Which means the chlorine must be reduced. Remember, you have to have one of each type. Redox, one of each. So what we're going to start off with today is exactly that. Here's 3 reactions. Tell me what element is oxidized and what element is reduced. How do you do that? Start by writing the oxidation states above each element. Go. Okay, check them. Hopefully you can read my handwriting. But you'll see this in multiple choice. 1, because you don't need a calculator, and 2, because it's just something pretty quick. So guys, let's get on to our main event. First things first, okay? What we're going to finish with today, okay, is the topic of balancing redox reactions. I put it in bold. In our textbook, the authors are named Brown and LeMay. In the Brown and LeMay textbook, this particular topic is covered not in chapter 4, but in chapter 20. Okay? And there is a reason it's in chapter 20. I tend to teach it now. So we're going to go over it now. But that, if you guys will recall, there was one question in our problem set, and I had it in bold that said, go to chapter 20. This is that topic right here. So, we're balancing redox. And I know what some of you might be thinking. You know, why does this get its own special attention? I mean, balancing, this is like Chem 1. Can't you just look from left to right and balance it? Well, no, you can't. Okay? For example, I want you to look at that equation right there. Do you see something? Just look at it carefully. Is there something, some reason why you might not be able to just balance it the regular way? Yep.
There's hydrogen on the right, not on the left.
You got it. There is hydrogen on the right and just mysteriously missing on the left. And that's a problem. Okay? You can't balance your normal way. So, there are a series of steps in order to do this. And if you have the PowerPoint slides, on this slide and the next, these steps are laid out for you. But instead of just reading through those steps, I'm going to work through them using this example. Okay, so if you have the PowerPoints, you'll see that I'm going through the steps. Might I recommend, wherever you're taking notes, you have a lot of space. Okay? You need a lot of space for these problems. So here we go. Step number 1 says, write separate reduction and oxidation half reactions. Okay? Well, as we've said before, guys, a redox reaction is going to have one element being reduced and one element being oxidized. We need to figure out what those elements are. So what do you suggest I do here to figure that out? What did we do on the last slide? Write the charges. Okay, so you guys tell me. Element by element. Aluminum, what do I got? 0. Okay. Manganese, maybe you don't know, but you do know oxygen. It's plus, careful, careful, there's a negative charge there. Plus 7. All right. Again, you might not be sure about manganese, but I do know oxygen, so plus 4. All right. Don't make this entire compound make you nervous. Okay, what is aluminum's charge when it's in an ionic compound? Plus 3. All right, and we're going to see these things are the same as they usually are. What 2 elements are the ones I'm going to be focusing on here? What are the 2 elements? One's being oxidized, one's being reduced. Aluminum and manganese. Okay, that's not magnesium, people. That's Mg. This is Mn, manganese. Fine. So it says to write separate what are called half reactions. And here's how I'm going to do that. You said aluminum is one of the elements I care about. You're right. Here is what its half reaction will look like. I'm going to write it exactly as it appears on the left-hand side. And I'm going to write it exactly as it appears on the right-hand side. Even if it occurs or appears in a compound, I'm going to write it that way. All right? So there is one of my half reactions. You guys said the other element I care about is manganese. You're right. I'm going to write it exactly as it appears on the left. Exactly as it appears on the right. Don't change it in any way. If it's within a compound, write it within the compound. Okay? Step 1, done. The next step says, balance all elements except hydrogen and oxygen, meaning don't balance those yet. So what elements am I talking about? I'm talking about aluminum. 1 aluminum, 1 aluminum. We're good. 1 manganese, 1 manganese. We're good. Okay? What if, guys, because this is going to come up when you start doing some practice, what if, I'm just making this up, let's say I had that. How would you fix that problem? Yeah, put a coefficient of 2 over here. Okay. Now, I didn't have to deal with that in this particular problem. Whoa. All right, but you will at some point. Okay. But that step is complete. Let's read what it says next. Then it says, balance oxygen, because you'll notice they're not in balance. Balance oxygen using H2O, using water. Please tell me, ladies and gentlemen, we're going to do this one reaction at a time. On this aluminum reaction, on the left, how many oxygens are there? 0. How about on the right? 4. Here's how I'm going to fix that problem. Okay? Do you all agree in this first reaction, do you agree that the oxygens are in balance? Do you agree? Okay. I'm not going to worry about the hydrogens yet. That's next. But let's look here. How many oxygens on the left? And how many? How do you fix that? How many waters and to what side should I add them? 2 on which side? You got it. Okay. So my oxygens are all in balance now. Let's go to the next step. It says balance hydrogen using H plus ions. Okay. Please tell me, on the left-hand side here, how many H's are there?
8.
8? How many on the right?
4.
Okay. Watch how I'm going to fix that. All right. How many hydrogens are on the left here?
0.
0, and on this side?
4.
Okay, so let's fix that. Okay. Now, before we go any further, let me address something that maybe some of you are wondering about. You know, how can you just put compounds there? How can you just put water and put H+? I mean, isn't conservation of mass the whole thing about you can't create matter? Well, guys, what does AQ mean again? Aqueous, dissolved in water. I did not just create this out of nowhere. It's there, okay? Water is there. And how about this guy? Okay, well, first of all, what you're going to see in the directions, it's going to say balance this redox reaction under acidic conditions, or it'll say balance this redox reactions in an acidic solution. If you guys remember from last class, an acid is by definition something that gives away H plus ions. So they're there, okay? I didn't just create this out of nothing. There are H plus ions floating around. Okay, now at this point, all of my elements should be balanced. But we still have an issue because these equations are not charge balanced. So the next step says balance charge using electrons. And this tends to be the step that is a little bit challenging for some people. Okay, so let me show you the thought process. Let's look at the aluminum reaction first. Okay, first of all, I want you to notice I am not going to write charges above each element because I'm not concerned with each element. I am concerned with the whole left-hand side. Water is a neutral compound. It has an overall charge of 0. So does this. So this entire left-hand side has an overall charge of 0. That is not the case on the right-hand side. Okay? Please observe, this whole compound has an overall charge of -1. This guy, there are 4 plus 1. So +4 plus -1, what do you get? +3, okay? When I say these equations are not charge balanced, this is what I mean. The left-hand side has a charge of 0. The right-hand side has a charge of +3. Watch how I'm going to fix that problem. Those are electrons. Electrons are negative. Do you all agree positive 3 plus 3 negative charges, that equals 0. And now these are in balance. Okay. Look at your second reaction. Can you tell me what is the overall charge on the left-hand side here? Plus 3. Okay. And the right-hand side, that's a neutral compound. That's neutral. 0. How many electrons and to which side should I add them?
3 electrons left.
3 on the left. Very good. Okay. Now guys, this is a multi-step process, as you are seeing here. It is a good idea every now and again to sort of stop, take stock, make sure you haven't made any mistakes, and this is a good place to stop and do that. Your electrons must be on opposite sides. Notice they're on the right here, they're on the left here. If you get to this point and you find that your electrons are both on the right or both on the left, stop and start over, because it means you've done something wrong. Okay. Now, the other thing to think about is that this coefficient, the number of electrons that are on the left and the number of electrons that are on the right, must be equal to one another. And we got lucky here because automatically they are. Tell me though, what happens if I ran into a situation like this, where this didn't have a coefficient of 3? To balance out the charge, maybe I only had to add just 1 electron. Well, they're on opposite sides, and that's great, but they must have the same coefficient, and right now they don't. If that's a problem, it says, if necessary, multiply by an integer to equalize the electron count. Ladies and gentlemen, what would I have to multiply this entire equation by to get those electrons equal? 3. I would multiply this entire equation times 3, which means this coefficient will change. This one, this one, this one. You adjust all of your coefficients. All right. Now, I didn't have to do that in this case because it just so happened for them to come out equal. Let me ask you this. What if that wasn't a 3? What if it was a 2? Yep. What would you multiply the top by?
2.
And the bottom one?
3.
Right. Multiply by 2, multiply by 3. So sometimes this can get kind of gross. Okay? That's why I said leave yourself a lot of room on the paper. Okay? Okay. Now, we're almost done. We're going to be adding these two half reactions together in order to get one big equation. Do you all remember something I said? I can't even remember when. But if you have something on the opposite sides of an arrow in an equation that are identical, you can cancel them out. Look at both equations together. Do you see anything that I can cancel out? Okay, electrons. And that should always be the very first thing to go. Because remember what I said. Your electron count, they must be equal. Okay? So my answer down here is never going to have electrons in it. That should always be the first thing to go. Do you see anything else I can get rid of? All right, the H pluses. Those are gone. Those are gone. Anything else? Okay, all of the water? Some of the water. I have 4 over here, 2 here. So those 2 are completely gone. But how many am I left with up there? 2. Okay, do you see anything else that I can simplify here any other way? No. All right, so let's write out what's left. It does not matter what order you write them in. This should be my final answer. Again, it's a good idea to make sure that everything looks good. Make sure all of your elements are in balance. Make sure your charge is imbalanced. If you did everything correctly, it should work out that that is the answer. Okay. Now, before you try some on your own, because I'm going to give you 2 that I want you to practice with, let me make some suggestions to you. All right? For the most part, you're going to see these kinds of questions on free response because they take a while, okay, and they require a lot of work. When I'm grading your tests and I look at your final answer down here, if anything is different than what I have, I'm going to look up above and see, okay, where did you go wrong? Did you just, miscount the number of waters or something like that? The point I'm trying to make is please show me as much work as you possibly can. Notice that when I canceled something out, I didn't erase it. I just crossed through it. Why do I say that? Because I need to be able to see, what did you do? If I can look up at your work and see, okay, you just made like an addition error or something, then you're only going to lose a point instead of 8 points, right? Write out as much as you possibly can and just pretend that you don't even have an eraser on your pencil. Just pretend it's not there. Don't erase anything, just lightly cross through it. Okay. So, I want you to try some on your own. Here are those steps that we just went through. I definitely want you to do numbers 1 and 2. If you get through those and you feel like, I've got this. Try number 3. It's a little bit more challenging, but 1 and 2 definitely. Guys, I'm pulling up the answer for number 1. Hopefully you can read my handwriting. Now, guys, just pause for a second. I just want to show you, I'm trying to model for you what this should look like on a free response. Okay? You'll notice that I didn't have to multiply this top equation times anything, but I did have to multiply this equation times 5, and I've written that out. Okay? That's a good thing for you to write out on your test. Now, why did I cross through it? Because this is really what that half reaction should be, and I didn't want to get confused because this and this is really where I want to focus. But the point is, I just crossed through it. I can still see what I had written. If I can still see what you had written, then you're more likely to get some partial credit. Let me say something before you go on. And I know some of you have already seen this. Can you all see that, let's say, for some reason, you thought this should be 3H2O instead of 4? Can you see that one small error is going to affect the entire problem? Yes. Okay? That is why I cannot stress enough how important it is for you to be as neat as possible and show me as much as possible. If I can see that you have a completely different answer than I do, but only because that should have been a 4 instead of a 3, you're not going to lose as many points. Okay? All right, I'll go back to the slide so you can see number 2. Let me just say something to save you a little heartache. I want you just to notice from the very beginning, there are 2 arsenics on the left There is only one on the right. Once you start this problem, you'll understand why I pointed that out. Okay, let's do this one. If you get through with it, try number 3. All right, let me put up the answer for number 2. And, oops, that's not what I wanted. I'm sorry it's so messy. The reason I called your attention to that imbalance in arsenic, if you forgot to put that 2 from the very beginning, that's going to affect the whole problem. All right, let me teach you one last thing in this chapter. Both of these problems that we just did, the directions said balance these in acidic conditions. Okay? What if you come across a problem that says balance this redox in basic conditions or in a basic solution? Now I know what you're thinking. Ugh, is that a whole new set of steps? No, it isn't. All right? If it's in a basic solution, you would do these exact same steps. Nothing different. There is just one extra step at the end. Okay, so I'm going to use this question as my example. If it said balance in acidic conditions, this is my final answer. If it said, however, balance in basic conditions, you have one final thing to think about. Okay, you get to this step and you say, where are my H pluses? Where are they? Here they are. If you are in a basic situation, here's what you do. And actually, I'm going to put this on the board. It's going to give me a little bit more space. Okay? So you find where your H pluses are. Here they are. If you are in basic conditions, you are going to add whatever that coefficient is, that same number of hydroxide ions, because that's what's in a basic solution. You're going to add it to both sides. And I can simplify this a little bit. What do you get when you put H plus and OH minus together? H2O. That's 4 waters. Well, I already have some waters. What's 7 plus 4? Thank you, 11. Okay, so let's simplify this a little. 11 H2O plus. That would be my final answer if it said balance in basic solution or under basic conditions. Okay. Let me just say one more thing and I'm going to give you a little more time to practice. What if my answer right here did not have any H pluses left in it? If you guys go back to the very first reaction we looked at today, the one that I walked you through step by step, go back and look at the final answer. Do you see any H pluses in our final answer? Neither do I. Guess how many OHs you would then add to both sides? 0. Which means, for that first example we did today, my answer, whether it's in acidic or basic, is going to be the same. Okay. So, I'm going to give you some more time to practice with this because that's what this really means. Okay? It's not that these problems are difficult, but it's very easy to make a small mistake, and a small mistake can affect everything. Okay? I am not likely to put a question like number 3 on your next test. And if you want a real challenge, you should try this one.